Hi everyone, you are welcome back to another interesting question. We are asked to calculate the area of this rectangle. This x we can see is the area of the small circle, and we can see this big circle here, its area is given as 4x, meaning its area is 4 times the area of this small circle. The length of this segment is 100 units. So how can we solve this? Well, it is very simple. The formula for calculating the area of a circle is pi r squared, where r is radius. But we have two circles. There are two different radii. Let's say radius of big circle equal to a and radius of small circle equal to b. So starting from the small circle, its area is x and its radius is b. Substitute here, so x equal to pi b squared. Keep it aside. For this big circle, its area is 4x and its radius is a. Substitute here, so 4x equal to pi a squared. And divide this equation by this. So 4x over x equal to pi a squared over pi b squared. Here x cancels x, while here pi cancels pi. So 4 equal to a squared over b squared. Multiply both sides by b squared. Here b squared cancels b squared, while here 4 times b squared is 4b squared. So 4b squared equal to a squared. That is a squared equal to 4b squared. Take the square of both sides. Here square root of a squared is a, while here square root of 4b squared is square root of 4 times square root of b squared. Square root of 4 is 2 and square root of b squared is b. 2 times b is 2b. So a equal to 2b. Replace this a with 2b. So radius of big circle equal to 2b and radius of small circle equal to b. We come here, draw the radius from the center to this point of contact and this also. Draw it to this point here. The radius of the small circle is b. So the length of this and this radius is b each. Now come here, draw the radius of the circle from the center to this point of contact, this and this. Recall, radius of big circle is 2b. So this and this each are 2b in length. From the circle theory, there is a rule that the tangent of a circle is perpendicular to its radius through point of contact. This side we can see is a tangent to the circle at this point. So by this rule, it will be perpendicular to the radius. So this is a right angle. The same is for this side here, which is a tangent at this point. It is perpendicular to the radius. So this is also a right angle. This line here is also a tangent at this point. So this angle is a right angle. Come to this circle also. This line, this side, and this are tangent at this point, this and this. Therefore, they'll be perpendicular to these radii. So this angle, this and this are right angles. Now to this rectangle, we know all the angles of a rectangle are right angles. That is, this angle, this and this are right angles. Now look at this quadrilateral. All its angles are right angle. This side and this side are equal in length. The only type of quadrilateral that has all 4 of its angles to be right angles and at least 2 perpendicular sides to be equal in length is a square. So the quadrilateral is a square-shaped quadrilateral. All sides of a square are equal in length. That is, this side, this, and this are equal in length. So since this is B, this and this must also be B in length. The same is for this quadrilateral here. We know since 3 of its angles are right angle, the fourth angle will also be a right angle. So this is also a right angle. Now this side and this side are congruent and they are perpendicular. That means the quadrilateral is a square-shaped quadrilateral. So therefore, this side and this side are also 2b in length. If we also draw the radius from the center to this point of contact, the quadrilateral is also a square-shaped quadrilateral. So this, and this will also be 2b in length. From this rectangle now, we know opposite sides of a rectangle are equal in length. That is, this side and this are equal. So since the length of this side is sum of this 2b and this 2b, which is 4b, this must also be 4b in length. But this segment is b, so therefore this segment will be 4b minus b, which is 3b. Now look at this line here. It is a tangent at this point. This line is also a tangent to the small circle at this point. We can see they are from the same external point. From the circle theory, there is a rule that if any two tangents are drawn from the same external point to a circle, then their segments are congruent. That is, this segment and this are congruent. So since this is 3b, this must also be 3b. The same is for this tangent and this tangent here. They are from the same external point. So by this rule, their segment will have equal length. So since this is 100 units, this must also be 100 units in length. Now let's assume the length of this segment to be C. Let's focus on this line and this line. They both are tangent at this point, and also from the same external point. So they'll have the same length. Since the length of this is the sum of this 3b and this c, this must also be 3b plus c. The next tangent we are going to attack now are this and this. They are from this same external point. So since the length of this is the sum of this 100 and this c, the length of this will also be 100 plus c. Now back to the rectangle. We know opposite sides of a rectangle are equal. So this side and this side are congruent. But this side is divided into two segments, which are this and this, while this is divided into four segments, this, and this. So since they are equal, the sum of this 3b plus c and this 2b must be equal to the sum of this b, this 100 plus c, this 100 and this 2b. So 3b plus c plus 2b equal to b plus 100 plus c plus 100 plus 2b. Here 3b plus 2b is 5b, while here 100 plus 100 is 200. b plus 2b is 3b. So 5b plus c equal to 3b plus 200 plus c. Subtract c from both sides. Here c minus c is 0, and here also c minus c is 0. So 5b equal to 3b plus 200. Take 3b to the left. So 5b minus 3b equal to 200. 5b minus 3b is 2b. So 2b equal to 200. Divide both sides by 2. Here 2 cancels 2. While here 200 divided by 2 is 100. So b equal to 100. Come here, substitute the value of b. 4 times 100 is 400. Here put b. 2 times 100 is 200. Come here also, replace b with 100. 3 times 100 is 300. And the length of this whole side is 300 plus c plus 200, which is 500 plus c. What is the value of c? We don't know. But from this triangle here, since it is a right angle triangle, we can use the Pythagorean theorem. The Pythagorean theorem states that the square of the length of the hypotenuse of a right angle triangle is equal to the sum of the squares of the length of the two other sides. The hypotenuse is the side facing the right angle, which is this side here. So by the Pythagoras theorem, the square of the length of this side, which is 3b plus c plus 100, must be equal to the sum of the squares of the length of this side, which is sum of this 3b and this b, and the square of the length of this side, which is b plus 100 plus c. So 3b plus c plus 100 all squared equal to 4b all squared plus b plus 100 plus c all squared. We have the value of b here to be 100. Substitute here. Now 3 times 100 plus c plus 100 all squared equal to 4 times 100 all squared plus 100 plus 100 plus c all squared. 3 times 100 is 300. 300 plus 100 is 400. Here 100 plus 100 is 200. 4 times 100 is 400. So 400 plus c all squared equal to 400 squared plus 200 plus c all squared. 400 plus c all squared is 400 plus c times 400 plus c, which is 400 times 400 plus c times 400 plus c. 400 times 400 plus c is 160,000 plus 400c, plus c times 400 plus c is 400c plus c squared. 400c plus 400c is 800c. So it is 160,000 plus 800c plus c squared. This 400 squared is 400 times 400, which is 160,000. 200 plus c all squared, if you expand, is 40,000 plus 400c plus c squared. 160,000 plus 40,000 is 200,000. This plus c squared will cancel this plus c squared. So 160,000 plus 800c equal to 200,000 plus 400c. Bring 400c to the left and 160,000 to the right. 800c minus 400c is 400c. 200,000 minus 160,000 is 40,000. So 400c equal to 40,000. Divide both sides by 400. Here 400 cancels 400, while here 40,000 divided by 400 is 100. So c equal to 100. Substitute it here. 500 plus 100 is 600. So the whole length of this side is 600 units. To calculate the area of this rectangle, we'll just multiply this 600 by this 400. So area of rectangle equal to 600 times 400, which is 240,000. So the area of this rectangle, which we are asked to calculate, is 240,000 square units. Thank you for watching. Please subscribe, like, share and comment, and also turn on notifications. Thank you.